Hi, here's a quick tutorial on how to fill in a repeated measures ANOVA table with just having a handful of the values. So what we know that we have 4 treatment conditions and we have 10 scores within each treatment condition. And why don't we go ahead right off the bat before we describe the rest of the problem and fill in our total number of scores. So if we have 10 scores in each treatment condition and 4 conditions, then we have 40 scores, so our capital N equals 40. That'll be important for calculating our degrees of freedom here in a second. So we know that our mean squares between treatments is 10. We know our sum of squares between subjects is 26. And we know that our total sum of squares is 110. And ultimately we want to calculate this F ratio. Okay, so the first thing you always want to do when computing an ANOVA is figure out your degrees of freedom. So between treatments, degrees of freedom we know is k minus 1, so k is 4, so it's 4 minus 1, which is 3. Okay, within treatments, degrees of freedom, we know that that is capital N minus k. Capital N we just calculated as 40, and k is 4, so our within treatments, degrees of freedom is 36. Now our between subjects, degrees of freedom is lowercase n minus 1. And we know that lowercase n is 10. We have 10 scores in each treatment condition, so 10 minus 1 is 9. We know that there's really no formula other than what we already have here in our numbers for calculating our degrees of freedom error. And we know that our between subjects degrees of freedom and our error degrees of freedom are partitioned out of our within treatments degrees of freedom. So knowing that, we can just subtract what we already know are our between subjects degrees of freedom 9 from our within treatments degrees of freedom, which is 36, and that gives us 27. Okay, and our total degrees of freedom is capital N minus 1. So capital N is 40, minus 1 is 39. Let's take a second to check ourselves. We know that these two add up, but it doesn't really make sense to go a long way to check those, because the only way to calculate error degrees of freedom is to check with between subjects and within treatments degrees of freedom. So let's focus on checking our total degrees of freedom and our between treatments and within treatments. We know that between treatments degrees of freedom and within treatments degrees of freedom are partitioned out of our total degrees of freedom, so therefore these two scores should equal this score, and as you see they do. 3 plus 36 equals 39. So we can be that much more confident that we've calculated our degrees of freedom correctly. So what else do we need to know to calculate our F ratio? Well, we need our our error mean squares, our mean squared error. So therefore we have to figure out our sums of squares. So we can start by figuring out our between treatments sums of squares. Now we know that our mean squares between treatments is 10, and we know that we calculate mean squares between treatments by dividing our sum of squares between treatments by our degrees of freedom between treatments. Now using that logic, we can go move in reverse order and actually multiply our mean squares between treatments by our degrees of freedom between treatments, and that gives us 30. Okay, so we can flip that logic around and then figure out our between treatment sums of squares. Now we know that our total sum of squares, which is 110, is partitioned into our between treatment sums of squares and our within treatment sums of squares. So again, using reverse logic, we know that between treatment sums of squares plus within treatment sums of squares equals our total. Therefore, we can just take our total sums of squares, 110, subtract 30 from that, and get our within treatment sums of squares, which is 80. Now using similar logic, we know that our within treatments sums of squares is partitioned into our between subject sums of squares and our error sum of squares. So we can just subtract 26, which we know is between subject sums of squares, from 80, which is our within treatment sums of squares, and we get 54. Now we're just about there. We need to get our mean squared error. We know that our mean squared error is calculated as our sum of squares error over our degrees of freedom error, and 54 over 27 reduces down to 2. our F ratio for a repeated measures ANOVA is calculated as our between treatments mean squares, or mean squares between treatments, over our mean square error, which is 10 over 2. So 10 over 2 equates to 5. So our F ratio is an even 5, and that's how you work through a repeated measures ANOVA table, taking just a handful of values and filling out the rest of the table, the sums of squares, the degrees of freedom, the mean squares, and ultimately the F ratio.